We're going to demonstrate Newton's first law of motion. It states an object at rest remains at rest, and an object in motion remains in motion along a straight line until a net force acts upon it. Okay, so we have a cup filled with water, a styrofoam plate, a bottle, and an egg. I'm going to place the styrofoam plate at the center of the cup, along with a bottle at the center of that cup, and an egg at the bottle, on the bottle. And I'm going to hit the plate, and it will take the bottle and the plate with the motion. The motion will take the bottle and the plate, and the egg will land in the cup. Newton's first law of motion says an object at rest remains at rest, and an object in motion remains in motion along a straight line until a net force acts upon it. Example. Kicking the soccer ball was an example of Newton's first law of motion because when Kendall kicked the soccer ball, it was the force, and when Lexi stopped the soccer ball, it was the net force. Newton's second law of motion states that the acceleration of an object is directly proportional to the force applied to an object and inversely proportional to the mass of the object. For example, this is an example of Newton's second law of motion because the force of the straw against the tissue was inverse to the mass of the tissue. Newton's second law of motion states, as we said earlier, that the acceleration of an object is directly proportional to the force applied to an object and inversely proportional to the mass of an object. For example, we have a tennis ball and a basketball, each of different masses. This example of Newton's second law of motion showed that an object with smaller mass accelerated further than an object with more mass. Newton's third law of motion states, for every action there is an equal and opposite reaction. As you see, I've blown up this balloon. It now has air pressure inside. It's not doing anything because I'm holding onto it. When I let go of the balloon, the pressure in the balloon will force the air inside the balloon to come out and will push against the air outside of the balloon, which will make the balloon flare out. As we said earlier, Newton's third law of motion states, for every action there's an equal and opposite reaction. Take this skateboard. When Beth pushes on the wall, she will roll backwards on the skateboard because she applied a force to the wall and the wall applied